Welcome back, tubers. Well, basically we're going to have a bit of fun for the first part of this video, but I promise you it's worth sticking around to the end because I am going to finish my most epic battery build and I'm going to put it into service. Well, maybe not into service because Australian regulations, but we're going to do something fun. First, this little guy is the happiest I've ever seen him. You know why? Check this out. Yeah. No stabilization footage here. What do you got for me, dude?
All from YouTube.
Surprise. Yeah. Giddy up. The box come damaged. Looks like they threw it out of the plane and delivered it to me that way. It's disappointing. Football or precious cargo is sometimes hard to tell. Is the UPS sports team practicing with my... Don't worry, I didn't need to get it in good condition. It's as long as it's okay in the box, right?
That's in the box. Finally, the YouTube play button came.
It's right here, matey. Show me it. You got to pick it up the right way, remember? We rehearsed this. Yeah! Right now, do a dance. Would you like to unbox it for me?
Yes, yes.
So I've got to say a big thank you to you lot. Without yous, I could never have done it. I would have never had the motivation, the desire or anything else to have 100,000 subscribers. So for that, thank you. And now on to my most epic build ever. 3 years later. Well, 3 years since I started the project. So for the new viewers, let's take 1 minute to run through how I got to this stage. So this battery actually started off life, I believe, as either a warranty replacement or scheduled replacement in a local school of 500 Acer laptops. And from that, I pulled approximately 3,000 NCR 18650 cells. So these little cells are rated at 2,900 milliamp hours each. It took me a full year to process down these cells, and each one of these cells was extracted from their little laptop battery case, like that. And each one was tested. So the testing procedure included doing a capacity test. And if you looked in the previous videos, you would have seen the capacity written on all of the cells. Now, each of the cells was tested for capacity, internal resistance, heat, so any heat that it showed when it was charging or discharging within the test. And then also it was left sit for a considerable, many months actually, for self-discharge. So if the cell had any internal problems or whatever, a lot of the times it would present itself two ways. Initially it would be heat, and then it would be just 0 volt. It would just drain itself to nothing. So all those tests were done over a period of a year. And I compiled them, sorted them out into nice even cells. And if you want more details, there's a couple of videos I'll link below. And then there's about 2,800 cells here. So it's 20 cells high and 10 cells deep. And then I've got 3 cells that are wrapped in blue here, and then 3 cells that are wrapped in blue underneath here. Now what those cells are, is they're in contact with the metal housing. So there's no chance of a negative to ground issue with this case. And then I've got nickel strip all along the sides. It's all spot welded on, and then soldered bus bars to that. And then they're joined together just with ring terminals. I'm not sure what they're called. And then we've also got some little balancing wires. So I've already run all the balancing wires and they come out here. Now each one of the balancing wires does have a fuse, so they're all fused. They're not connected at the moment. And then they're all housed in this fireproof 86 kilo old maps cabinet. So it's a recycled maps cabinet. Now down the bottom, I've installed 2 fans. So they've just got little little covers over the top, little magnetic covers. They sit over the top. So the fans will be down the bottom, and then they will circulate air. And there's actually a small gap here where the hot air can rise and come out. So I don't think those fans are ever actually going to be needed. Installing the electronics is proving to be a little bit tricky, and to be honest, is one reason why it's taken so long. I simply can't decide. I just asked my wife, she was no help. Go figure. So this is where we're at the moment. In this little box, this is my little electronics box. I've got a, what's that, 17 to 50 volt to 24 volt converter, and that'll run 2 fans in series. And then we've got a shunt trip, so that'll be activated by the BMS. So should we have any low, high temperature or low, high voltages of individual cells and or the entire battery, that'll trigger. We've got a shunt, so we can measure the in and out of the battery, so we know the actual capacity. And we've got a Watchmon 5 with an expansion board with solid state relays on it. So this is a little bit older model, but I did get this a couple of years ago. Given the choice, I would have bought a new one. I would have gone to Watchmon Core. They seem to be the go-to at the moment, but this will work fine for this application. So I've had this challenge of how to lay out this box, and I've gone through iteration after iteration. Now, one of the design considerations is this has got to flow nicely and, you know, solve my OCD issue. So we got that, which is a shunt, and the way I was hoping it would come in, the negative and positive would come in here and then exit out the top. And when it exited out of the top, I've got these mounts so I can go through the tin, so they're nice and safe. But we've got to have negative coming from the battery up into this, out of this, through the shunt trip or the breaker, the DC breaker, and then out the top, and then the positive has got to come through and back out the top again. So no matter where I put this in here, it doesn't really work. And I wanted to make it aesthetically pleasing, right? So let's try and work this out. Wonder if that'll work. I've always been trying to get the shunt inside of the box. So the box sits like that in there. Well, that's how I envisioned it anyway. I really do want this whole thing to be super tidy and really professional. I can simply run it up there, but then that gets in the way of the actual cable itself unless I run it sort of there. So the negative and the positive can come out beside each other. Now I have the negative is up here, and then the positive is down on the lower cells there. So that's down there, that'll be number 1 or number 14 depending on which way the BMS goes. So that cable there will come straight up underneath inside that box, and the negative is going to have to come down, loop around and then go up. It may actually even be better down here. So then the positive cable will come up, and then the negative cable will come down onto here and then straight up back up into there. So that actually might be the neatest way I can do that. I'm not liking putting it on the back, but I think that's going to be practical and work the best. Alright, happy that bit went to plan. Looks alright. This is what I'm talking about, ACD. I would have liked that to be sort of straight across the top. It won't matter for now. Right, next. Cables to the top and bottom. Sort of want them to come through nice and close down the bottom there. So 2 holes there and there, I reckon. It's tight, but it's not too tight. Probably run a file through that. That's much better. There we go. So that'll come through the bottom. So do one beside it as well. Eagle eye it, see what happens. He's put in its fab shop. Beautiful. That'll do. Doesn't need to be too tight. Trying to appease the OCD gods. Made a little bit of a template, so it sort of sits there. I put the same thing on this side. Hopefully it looks half consistent. Hey, you'll never be able to see it, but that's close enough. So we've got the DC coming in and then the DC coming out. And we've got the battery management cables and fan cables going through there. Alright, next step. Well, that went bad quickly, or actually it's good quickly. What have we got? Got that up there. Kind of sweet, sits in there well. Procrastination was my worst enemy. I kept changing my mind. At the end of the day, I should have just done it. So the negative up there comes down to the shunt, and the positive comes there, and they both come in to the bottom of there. And now the part I'm really dreading is this loom. I've wrapped it up a little bit in tape to try and protect it from pulling it in and out the hole. I started this earlier this morning, and the sun's gone down now, and progress has been made, but it's not as much as I would have expected due to a few unforeseen issues. Wiring in the battery management system, I have a fault. I haven't researched said fault yet. Fail C14, C15, I don't know. I think it's actually the jumpers here, but it's too late. I've had enough. I'll be back tomorrow. Next morning, and I work into a bomb site. One of the biggest challenges by far is finding specific tools, or the right size ferrules, or the right size crimpers. Yeah, first world problems, right? So I did a little bit more after I signed off last night because I just couldn't sleep. So I got the Watchmon 5 all sorted. I had a few problems with my wiring, more specifically. Where is it? It's gone. Can you believe it's gone? Basically, I had a few of these because they'd just been sitting around for so long. I had a few end bits were corroded because I didn't have fuses in them. So got fuses for there. So that was a bit of a challenge to work out all those faults, but I have now. So it's in there blinking away, so it's balancing. This cell here was the cell that was leaking, so it was a little bit higher than all the rest because it wasn't balanced. But I'm really happy with the way that has actually held up over time. Today we have tidying up all that BMS wiring and work out where I'm going to actually put these two terminal lugs. See, this is my problem. Everything just gets moved. These terminal lugs, rightio. The plan was sort of to put them there, so one there and then one beside it. And then I've got little covers for that. So that plastic goes through, sits like that. Battery change, go from the 3 amp hour to the 9, should give me a few more amps, and it does. Now it's binding up here. Boom. That's exactly how I hoped it'd look. Nice and clean, no lateral movement, just slides straight in there. Couple of screws, get it all squared up, it should look good. That'll work. Last weekend got away from me a little bit, but throughout the week, in my spare time, made a little bit of progress. Let me run you through what I've done. Now, for those who haven't seen how this enclosure works, it's an old maps cabinet, like I said at the start. The lid opens up and there's 4 clamps on the corners. It used to just swing forward. I've modified it a little bit to suit my needs. So the 1, 2, 3 and 4 clips, you do the top ones first. This door is quite heavy. I think it exceeds 10 kilos just for the door alone. It's 2mm steel, and in some places it's double skinned. and it's resting on a little L bracket at the bottom, stopping it from hitting the ground. I'll lift that off carefully. I've got it to one side. So I finally got through with all the fans and all the automated stuff through the battery management system. Now, if you want a specific video on how I set all that up, what it does, and a little bit more detail, I'll be happy to go into that in a different video with enough interest. Leave a comment below. And on the same token, while you're at it, if you like what I do, thumbs up, subscribe if you haven't already. That would be much appreciated, because I honestly can't do this without yous. Now this turned out really, really well, much cleaner than I expected. The covers went on well after I trimmed down the lugs a little bit. I took about half a centimetre off the lugs on the inside and on the outside, so they sit in there nice. It's a similar story on the outside. I like the finish of it. It's going to do the job quite well. So those little terminal covers will sit over those terminals. Job done. Connected inverter up, charger, whatever. Now the electronics box. So I've got the Watchmon 4 here with the fan, and then beside it I've got the Watchmon expansion board, and then beside that I've got the DC to DC converter, and then beside that I've got a shunt trip. So that shunt trip here is actually this bit here, and that's a breaker. It actually trips a breaker. That goes over into the power, and then over into the Batrium, into the expansion board onto the relay. And then whenever these lights come on, so these are the balancing lights, it'll turn the fans on. And similarly, whenever there's a critical fault, this will trip. So a quick rundown on how the fan and the shunt trip kind of work. I can click on menu and then go hardware, and then go expansion, and we've got Watchmon 5 plus expansion, and then we've got critical fault on relay 3 when everything is not okay. So that is actually on the shunt trip. And then on relay 4 here we've got bypass running. So that is basically when those little red lights we saw earlier were flickering about. So they can also be seen on the chart, and the red lights up here. So that's where it's in bypass mode, when it's actively balancing the batteries. So we go back to hardware, go back to expansion. Now if I want to create a critical fault, I click on edit, I click on critical fault, and then I go all the way to the top, and then I can go manually on. So if you watch over here, when I click OK, I click on manually on, and then I click save. Just watch over here for a second. I click on save, and it triggers. So, and consequently that also turns the fan off. You can just see it's not spinning there. So we can reset that now. We go back to here, we go to edit, we go to manual on. For now we'll just turn it off, none, save, and then we can reset that. So the fan turns back on again. Now if we want to turn the fan on or off, we can also go to menu, hardware, so we're already there, cell monitor, and then edit, and then I can change this voltage here. So it's 3.84 volts, and that's where I want it to settle to. It's a little bit below that at the moment, but that'll almost get it balanced out well. So if I change that from, say, just go up by a few volts, hit on enter, on save, the fan turns off, it stops spinning. So only when it's balancing will the fan actually come on. Now with all the electronics sorted, we have one more thing to address, and it's probably the most serious thing that I need to sort out with this build. The last problem, and many others have pointed it out in previous videos, is these mounts, although they're working just sitting here, ever so slowly, these mounts are working their way up and will eventually get so high it lets the entire cell fall backwards and cause a problem. Fortunately, this problem was quickly remedied with a little bit of scrap timber, a couple of nuts and some threaded bolt, and a little bit of plastic sleeve. That's just gone through the back there to the front, and is more than capable of holding all that in. And that, my friends, concludes this build series. So sit back and enjoy a couple of beauty shots, and I'll see you on the next one. and then do the dap or something. Okay, you start dancing everywhere, right?
Okay.
You dance here, you dance on top of the bench, you dance on the mailbox, you dance
Not on there.
on there.
No.
And I'll get you dancing everywhere, and then I'll edit it all together in a crazy dance move, and then you can open the box. Okay, look at me. Okay, so what's in the box, Dad? And then start. Like doing the dap or something. Or doing the floss or something, or both, or all of them at once.
Is the YouTube play button in the box?
I can't film you down there, mate. Oh, this is not going to work.